First, we open the new menu inside Chart Builder. We create a fresh chart, give it a descriptive name, and then select the application type and the target device we want to deploy it to. Once the chart is created, we can choose among the available chart types and pick the visualization that fits our process best. In this case, we go with the line chart. Now we configure all the parameters for the x-axis. We define how many points the chart will display on screen. We pick the format used to render the timestamps. We choose how many time divisions to show on the axis, and we set the labels. After that, we move on to configure the datasets. Here we assign the positions for the x, y, and z-axis of the values we want to plot on screen. For each dataset, we can pick a descriptive label, a custom color, a unit of measure, and a minimum and maximum scale value to fix the range. Or, by leaving 0, 0, the scale automatically switches to auto scale and adjusts dynamically to the data. In the theme section, we pick a reference theme, which defines the color palette to apply to the chart. Right after, in the styling section, we choose how the data will be drawn. We can render the data as plain points, as a step shape, or as a fully filled area. Next come the selection tools to fine-tune the look. Once we've decided all of this, we land on the main page where the chart is fully displayed. Through the Simulation tab, we can generate sample data and watch in real time how the chart behaves with our settings. And we can also fine-tune the properties, the parameters, the themes, and the styles directly inside the chart builder without leaving the workspace at any moment. On this page, we can manually set every parameter. We define the unit of measure. We adjust the scale, the line style, the area fill, the colors, and every other editable property of this chart. We can adjust them one by one directly here, or reopen the wizard and go through the guided flow again to set everything definitively. Beyond these, all the tools you see on the right side panel can be enabled or disabled with a single click. We can pause the chart in real time or integrate measurement instruments like minimum limit levels, maximum limits, and reference levels to highlight specific points on the chart. We can also use cursor measurements, placing cursors at chosen positions and reading off the differences between them on screen. Once we've defined all the properties and tested the chart in simulation, we move to the preview section. We click Generate Core, then Generate Preview to inspect the final result, and finally generate CVC to package the component. Once generated, the CVC is created and automatically downloaded onto our PC as a packaged archive. From there, we extract the contents of the CVC and access everything we need to deploy the chart on a panel. And inside the archive, we also find the user manuals and the full technical documentation, all ready to copy straight into our project. Once copied into our project, we import the component into TIA Portal simply by dragging it inside the workspace. And then we start defining the object properties. Here we find exactly the same properties we set earlier: the X, Y, and Z axes, the tools, the max points, the format, the division, the update time, every parameter we already configured in the chart builder, ready to carry them straight over. Now we can connect each property to the reference tag inside the project. In this example, we link to the process value, the real value coming from the PLC that we want to trace. We assign the process value to the x-axis, to the y-axis, and to the z-axis, so every channel of the chart points to its corresponding PLC tag. Once all the values are connected, we compile the CVC and download it directly onto our operator panel, ready to run. So in just a handful of steps, we've been able to define the entire chart from scratch. We picked the chart type. We set every axis and every parameter. We modified and parameterized it. We downloaded the component. We loaded it into TIA Portal. We compiled the runtime project, and we deployed it to test the chart directly in the runtime environment. All of this in just a few minutes of development, as you can see directly from the live chart running on the screen. Now let's log into the WinCC Unified runtime and see it actually live. We open the reference page on the panel. Inside the page, we can see that our chart is already active and acquiring data in real time. The values shown are different from those in the preview because these are the actual measurements being collected by the PLC. We can stop the chart at any moment to inspect the individual sample points using our tool. We can then measure the differences between one point and another using the level indicator. After that, we can restart the chart, switch on the auto range on the scales so they adapt to the incoming data, configure the zoom level, and add more measurement instruments on top. In this case, a cursor measurement, which lets us compare 2 points and read the difference between them on every single axis. We can also add limit lines and drag them around to check whether the chart goes beyond a given threshold or stays within the safe range. This is very useful whenever we want our charts strictly under control. We can also split the view of the chart, dividing it horizontally or vertically, so that each dataset gets its own dedicated area inside the chart and is easy to read. And we can move, inspect, and zoom into every chart marker independently. Through the same set of tools, we can pause the chart at any time, zoom in on a region of interest, move along the scale, and pan around freely with the panning control. Navigating freely inside the chart, we can zoom in on a very distant or very small point, bringing every single sample and every trend of the chart under complete control. Finally, we can disable any dataset on the fly, viewing only one dataset at a time to isolate it from the others, or viewing all of them at once whenever we need the full picture. So if you have maybe 10 datasets, instead of overlapping all of them at once, we can simply look at them one at a time.